All right, next topic, molar mass. Page 3 in your packets. All right, so at the top of your packets it says molar mass is the term given to the weight or mass in grams of 1 mole of an element, molecule, or formula unit. On the periodic table, the molar mass is indicated by the atomic mass. For example, the molar mass in 1 mole of hydrogen is 1.0079 grams. So if you go to the periodic table, and I suggest you do, you would see hydrogen. It's element number 1, so it has an atomic number of 1. And then like it's saying here, the number underneath it is 1.0079. Well, when you go to the periodic table, we know that this is the abundance of the isotopes, right? But here's how awesome the periodic table is. This also tells you something called the molar mass. Now, a couple of videos ago, I had a video talking about what is stoichiometry, right? And that video said that in 12.01 grams of carbon, there was 6.02 times 10 to the 23rd atoms of carbon, right? Well, these two things are equal to each other. So it's not a surprise when you go to the periodic table and you go find element number 6, which is carbon. Its mass, or its number underneath it, is 12.01. Again, this is the mass of a mole, thus the term molar mass. And so everything you see on the periodic table, you have another example here, where you have aluminum. I believe it's element 13. And underneath of it, 26 point, and it's going to give you the full one here, 982 is what's underneath. What does that mean? It means that in 6.02 times 10 to the 23rd atoms of aluminum, the mass would be 26.982 grams. So, pretty awesome that we could take these, weights, and they're the molar mass. Again, another way in which Mendeleev's periodic table is so awesome. And let's not, not give due credit to that Avogadro guy who came along and came up with this idea of a mole and molar masses. But the fact of the matter is, Mendeleev was just absolutely a genius in the way that he organized his periodic table. So, Cl, right? Chlorine is what you see on page 3. And it wants you to go find the molar mass of it. Well, what you do is you're going to go find the molar mass of chlorine. When you go to the periodic table and you look up the molar mass of chlorine, the number that you come up with is, I think it's 35.4527. So 35.4527. Now, and that would be grams because it's the molar mass. A suggestion I think we should do. With regards to masses, molar masses, I would round them so we have a significant figure. We just have consistency to the hundredths place. So I would make this 35.45 grams. So whenever we're doing a molar mass, let's just make that the way we do it. We round to the hundredths place. Ca, so we go find calcium on the periodic table, and you look it up, and it's 40.078. Well, we're going to round to the hundredths place like we just said, so we're 40.08 grams. Now, these are atoms here, right? But we said that moles can apply to molecules and to this thing called a formula unit. So, the next set down talks about for the following molecules. Here's where it gets awesome. Well, we have a molecule known as CO2, right? Carbon dioxide. Here's what you do. You go find carbon. Carbon, as we just said before, is 12.01 grams. Round to the hundredths place. But there's not only carbon, there's 2 oxygens here. So we got to add to it, and we got to add in the oxygen. Well, there's two of them, right? So I'm going to put it in parentheses, and there are two. I'm going to multiply that by the molar mass of oxygen. Now, oxygen is 15.9994, I believe. Yeah. And so 15.9994, when you round to the hundredths place, becomes 16.00. Well, when you take 12.01 plus 2 times 16, and that would be grams, you get a number. Again, we're going to round to the hundredths place. So I believe it's 44.01 grams. And that's the molar mass of CO2. There's the copper, there's the two oxygens. SO2, sulfur dioxide, is the name of it, right? Hopefully we recall that. 32.066 is sulfur, so that rounds to 32.07 grams. Always to the hundredths place. We still have two oxygens, 15.994 rounds again to 16.00 grams. You take 32.07, you add 2 times 16, and so that's 64.07 grams. Again, we're always going to round to the hundredths place. Then two more. Okay? Sometimes we're talking about formula units. Well, NaCl. Now, the reason we call these things formula units, let's real quickly cover that. So, atoms cannot be broken down into smaller, right? Atoms are the smallest indivisible particles that make up elements. Molecules can be broken down into individual atoms. That's what we call them molecules. Like this can be broken down into carbon and oxygen. This, formula units, when it gets broken apart, it makes ions, right? You have a +1 sodium ion and a -1 chloride ion. And as such, when they break apart, when they dissociate, like in water when we're doing net ionic equations, you end up with these things being apart. And so that's why we give them this different name of formula units. I don't know if I explained that before, but that's how you get it. So NaCl, back to the molar mass. Well, you have 1 sodium and 1 chlorine. So you go find sodium on the periodic table, and when you find sodium on the periodic table, I think you get 22.99 when you do. So it's 22.99 grams for sodium. Then you got to go find chlorine. We set it up here, 35.45 grams. You add these two things together, you round to the hundredths place. I think it's 58.44. Yeah. 58.44 grams. And that's the mole. This is the mass that would be in 6.02 times 10 to the 23rd formula units of NaCl. So if we were to look at the itty bitty little crystals that make up one NaCl formula unit, I mean, you couldn't even put it in your fingers, okay? If we did that, then you'd have 6.02 times 10 to the 23rd of them weighing 58.44 grams. Again, the reason moles in stoichiometry exist is because this I can actually grab onto. I can do laboratory experiments with it. But shoot, I can't do that with one molecule of NaCl. It's just too tiny. How about CaNO3 This is tricky, so let's go over it. Because of the parentheses, it distributes, right? So here's how you do this one. You take Ca, since there's only one of them, and it's 40.08. It's above us. Now here's where it gets a little weird. This 2 distributes to the end, so that gives us 2 nitrogen. So it's plus 2 times nitrogen, which is 14.01 grams, plus 2 times 3, because it's distributive properties. There would be 3 oxygens, and there would be 2 of them, right? So 3 and 3 is 6. So 6, I'm going to put this in parentheses, times the molar mass of oxygen we just established was 15.9994, right? Which rounds to 16.00 when we round to hundredths place. So here is the calcium. This is the 2 nitrogens, and this is the 6 oxygens. We take these things and we add them together. And when we add them together, I hope you can see this at the bottom, and we round to the hundreds place, it's 164.10 grams. And that is the molar mass that would be in 6.02 times 10 to the 23rd CaNO3 2s. A lot, it would weigh a lot more than, you know, a mole of NaCl. And that makes sense, right? Because atoms have different numbers of protons, neutrons, and electrons in them, and thus have different masses. And that's how you do it. Molar mass.